In the reaction B2O3 plus C plus Cl2 gives A plus CO. The A is either A BCl3, B BCl2, C B2Cl2 or D CCl2. Now let's look at what the reaction takes place. Now B2O3 plus 3C plus 3Cl2 gives 2 BCl3 plus 3CO. Therefore, BCl3 is the product obtained by passing chlorine over the heated mixture of B2O3 and powdered charcoal. Therefore, here the correct answer is BCl3, which is option A. Organic benzene is A B2H6, B B3N3H6, C B3O3H6 or D BH3 slash thrice. Now, borazine, which has the chemical formula B3N3H6, is isoelectric to benzene and hence it's called inorganic benzene. But some physical properties of benzene and borazine are also similar. Now here is the structure of a borazine, which is H, B, double bond, N, H, B, H. Here N, double bond, B, here H, NH, and then it forms a double bond with another nitrogen atom, and here H. This is the structure of borazine. Now comparing that to the structure of benzene, which is H, C, double bond, C, C, double bond, C, C, double bond, C, and C. We can find many similar properties with benzene and borazine, such as the placement of the double bonds and many other things. Therefore, here the correct answer is B, which is borazine. When aluminium is added to KOH solution, A. No action takes place, B. Oxygen is evolved, C. Water is produced, or D. Hydrogen is evolved. Now let's look at how the reaction takes place. Therefore, 2 KOH plus 2 Al in the presence of water gives 2 KAlO3 O2 plus 3H2. Hence, when Al is added to a KOH solution, hydrogen is evolved. Therefore, the correct answer here is option D. Hydrogen is evolved. Boron cannot form which one of the following anions? A. BF6 3 minus, B. BH4 minus, C. BOH minus 4 or D. BO2 minus. Now, due to the non-availability of d orbitals in boron, it is unable to expand its octet. Therefore, the maximum covalence of boron cannot exceed 4. Therefore, here the correct answer that boron cannot form BF6 because the maximum covalence cannot exceed 4. Therefore, the correct answer is option A. Metals has a greater tendency to form metal oxide, either A. Aluminium, B. Calcium, C. Chromium, and D. Iron. Now, the formation and stability of metal oxides can be explained on the basis of lattice energy effects. Now, Al plus iron, being a small ion, has a strong positive field around it and can stabilize O2 in a better way. Therefore, here A can form aluminium has a greater tendency to form metal oxides, which is option A. The following give propyne on hydrolysis: A. Al4C3, B. Mg2C3, C. B4C, or D. La4C3. Now, propyne can be prepared by the hydrolysis of magnesium carbide, which is Mg2C3. The reaction goes as this: Mg2C3 plus 4H2O gives CH3C triple bond CH plus 2 MgOH twice. Hence, this gives propyne on hydrolysis, which is this. Therefore, the correct answer is option B. Lead nitrate on heating give lead oxide, nitrogen dioxide, and oxygen. This reaction is known as A. Combustion, B. Combination, C. Displacement, or D. Decomposition. Now let's look at how the reaction takes place. Now, lead nitrate on excessive heating gives 4NO2, which is nitrogen dioxide, plus 2PbO, which is lead oxide, plus O2, which is oxygen. Now, this is known as decomposition reaction because lead nitrate decomposes to form heating decomposes to form lead oxide, nitrogen dioxide, and oxygen. Therefore, the correct answer here is option D, decomposition reaction. The stability of dihalides of Si, Ge, Sn, and Pb increases steadily in the sequence. Here are the sequence given. Now we need to identify the correct sequence. Now, due to the inert pair effect, the stability of +2 oxidation state increases as we move down the group. Therefore, the correct order of these will be SiX2 is less than or equal to GeX2 is less than or equal to SnX2 is less than or equal to PbX2, which is option C. Therefore, the correct answer is option C. Preparation of amorphous silicon HF acid is used to remove A. Magnesium, B. SiO2, C. Silicon, or D. None of these. Now, amorphous silicon is prepared by the reduction of silica, which is rocks. Now, HF is added to remove SiO2 to obtain the extra pure silicon, therefore SiO2 is removed by the addition of 4HF, which gives SiF4 plus 2H2. Therefore, the correct answer is option B, SiO2. Gases are absorbed on A. Anhydrous CaCl2, B. Charcoal, C. Concentrated H2SO4, or D. Coconut. Now, noble gases are found in very minute amount in the atmosphere. These are separated from each other by using coconut charcoal, which absorbs different gases, at different temperatures. Therefore, here the correct answer is option B, charcoal. Use of which of the following fertilizer increases the acidity of soil? A. Potassium nitrate, B. Urea, C. Superphosphate, or D. Ammonium sulfate. Now, ammonium sulfate, which is NH4 twice SO4, is a salt of strong acid and a weak base. Therefore, on hydrolysis, it will produce H plus ions. This will increase the acidity of the soil. Now, let's look how the reaction takes place. Now, NH4 twice SO4 is divided into decomposes into 2NH4 plus SO2, SO4 2 minus. Now, when it undergoes hydrolysis, it forms NH4 OH plus H plus. Therefore, H plus is evolved, and this in turn increases the acidity of soil. Therefore, the correct answer is option D. On heating a mixture of NH4Cl and KNO2, we get A. NH4NO3, B. N2, C. N2O, or D. NO. Now, let's look at what will happen. Now, NH4Cl plus KNO2 when reacts, it forms NH4NO2 plus KCl, which will again react and give us N2 plus 2H2O. Therefore, here the correct answer will be N2. We get N2 on heating a mixture of NH4Cl and KNO2. NO2 is a mixed oxide is proved by the fact that with NaOH it forms A. Nitrite salt, B. Nitrate salt, C. Mixtures of nitrate and nitrite, or D. Ammonia. Now, NO2 when dissolved in water gives a mixture of nitrous acid and nitric acid, which is 2NO2 plus H2O gives HNO2 plus HNO3. Therefore, when NO2 is dissolved in water, it gives a mixture of nitrous and nitric acid. Now, this nitrous and nitric acid on passing with on heating with NaOH gives mixtures of nitrate and nitrite, which is NaNO2 plus NaNO3 plus 2H2O. Therefore, the correct answer here is option C, mixtures of nitrate and nitrite. Nitrogen trihalides is least basic: A NF3, B NCl3, C NBr3, or D Ni3. Now let's look at option A, which is NF3. This is the structure of NF3. F F. Now it is the least basic because of the high electronegativity of the three F atoms. The lone pair present on the nitrogen atom is not easily available for donation. Therefore, this is the most least basic trihalides. Therefore, the correct answer is option A. The lowest boiling point: A NH3, B PH3, C A5H3, or D SbH3. Now let's look at the boiling point of every compound here given. Therefore, NH3 has a boiling point of 238.5. pH3 has a boiling point of 185.5. ASH3 has a boiling point of 210.6, and SbH3 has a boiling point of 254.6. Therefore, here the correct answer is the pH3, which has the lowest boiling point. Bond angle is minimum for A H2O, B H2S, C H2SE, and D H2TE. Now, H2O has a bond angle of 104.5 degree. H2S has a bond angle of 92.1 degrees. H2SE has a bond angle of 91 degrees, and H2TE has a bond angle of 90 degrees. Now, why is the bond angle decreasing? It is because as we go down the group, the electronegativity decreases, due to which the repulsion between the bonded pairs of electrons also decreases. Hence, the bond angle decreases. Therefore, H2TE has the lowest bond angle. Therefore, the correct answer is option D. Zone with Ki solution produces A Cl2, B I2, C Hi, or D IO3. Now let's look at how the reaction will take place. Therefore, 2Ki plus H2O plus O3 will give the reaction products as 2KOH plus I2 plus O2. Therefore, I2 will be the product formed. Therefore, the correct answer here is option B. H2S is passed through acidified KMnO4, we get A K2SO3, B MnO2, C KHSO4, or D sulfur. Now let's look at how the reaction takes place. Therefore, KMnO4 plus 3H2SO4 plus 5H2S on reaction will give the answer as K2SO4 plus 2MnSO4 plus 8H2O plus 5S. Therefore, the product formed will be K2SO4 and S, which is sulfur. Therefore, the correct answer is option D, sulfur. Which compound acts as an oxidizing as well as reducing agent? A SO2, B MnO2, C Al2O3, or D CrO3. Now, the minimum and maximum oxidation number of S is equal to -2 and +6 respectively. Now, since the oxidation number of S in SO2 is +4, therefore it can be either increased or decreased. Therefore, SO2 behaves both as an oxidizing as well as a reducing agent. Therefore, the correct answer is option A, SO2. The following hydrides has the lowest boiling point: A H2O, B H2S, C H2SE, or D H2TE. Now let's look at the boiling points of the four compounds. H2O has a boiling point of 373 Kelvin. H2S has a boiling point of 213 Kelvin. H2SE has a boiling point of 269 Kelvin, and H2TE has a boiling point of 232 Kelvin. Now H2S has the lowest boiling point and H2O has the highest boiling point because due to the H bonding, the boiling point of H2O is higher. Therefore, the lowest boiling point is of H2S. The correct answer is option B. Chlorine reacts with sodium hydroxide under various conditions to give A. Sodium chloride, B. Sodium hypochlorite, C. Sodium chlorate, and D. All of these. Now let's look at the under cold conditions how NaOH reacts. Therefore, 2NaOH, which is dilute, plus Cl2 under cold condition gives NaCl plus NaClO plus H2O, which is sodium hypochlorite. Now, under hot conditions, concentrated NOH reacts with Cl2 to give 5 NaCl plus NaCiO3, which is sodium chlorate, plus 3H2O. Therefore, under various conditions, we get sodium chloride, sodium hypochlorite, and sodium chlorate as the answers. Therefore, the correct answer is D, all of these. KBr is treated with concentrated H2SO4, reddish brown gas evolved is mixture of bromine and HBr, B HBr, C bromine, and D none of these. Now let's look at how the reaction takes place. So 2KBr is treated with H2SO4 plus MnO2 on heating will give 2KHSO4 plus MnSO4 plus 2H2O plus Br2. Therefore, bromine, a reddish brown gas of bromine will be evolved when KBr is treated with concentrated H2SO4. The correct answer is option C. Following is isolated in pure form: HCI, HClO4, HClO3, HClO2, and HClO. Now let's look at the various action. Now, option D is HClO. It decomposes to give Cl2 and H2O water. Therefore, it is not obtained in the pure, isolated in a pure form. Now, option D is HClO2. This also undergoes auto-oxidation to give HClO and HClO3. Now, HClO3, option B, which is HClO3, is stable only in the dark. Now, if there is a presence of light, it releases chlorine and thereby acts as an oxidizing agent. Now, option A, which is HClIO4, is very stable one, and hence it is obtained in the pure form. Therefore, the correct answer is option A. Of chlorine from HCl, MnO2 acts as an oxidizing agent, B reducing agent, C catalytic agent, or D dehydrating agent. Now let's look at the reaction of the preparation of chlorine from HCl. Therefore, MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. Therefore, in the preparation of chlorine, here Mn2O2 has an oxidation number of +4, where it goes on reduction, and hence oxidation number reduces to +2. Therefore, here MnO2 acts as an oxidizing agent, and therefore the correct answer is option A, oxidizing agent. The manufacture of bromine from seawater, the mother containing bromides is treated with CO2, B Cl2, C I2, and D SO2. Now, let's look at what the mother containing bromides is treated with. Now, if MgBr2 is treated with chlorine, it will undergo a reaction and form MgCl2 plus Br2, which is feasible. Therefore, here the mother containing bromides is treated with Cl2 to form MgCl2 and bromine. Therefore, the correct answer here is option B. Of XCO3 is A linear, B planar, C pyramid, and D T-shaped. Now in XCO3 there are a total of 4 electron pairs around the central atom, out of which 3 are bonding electron pair and 1 is non-bonding electron pair. Therefore, the 4-3-1 combination provides sp3 hybridization and a pyramidal shape. The shape of XCO3 is Xc double bond O, double bond O, double bond O with a pyramidal shape. Now, therefore, this structure is known as a linear structure. Therefore, the structure of XCO3 is linear, which is option A. The following gases exist more abundantly in nature than the others: A. Helium, B. Neon, C. Argon, and D. Krypton. Now let's look at the gases. So the gas first is helium, and its abundance in air by volume, which is ppm, is 5.2. Neon, its abundance is 18.2 ppm. Argon has an abundance of 93.4, and krypton has an abundance of 1.1. Therefore, here option C, which is argon, has the highest abundance in nature, which is the correct answer. So the following is not obtained by direct reaction of constituent elements: A. XCF2, B. XCF4, C. XCO3, and D. XCF6. Now, XCF2 is prepared by Xc and fluorine in the presence of the Ni tube at 673 Kelvin to give XCF2. Now, XCF4 is prepared by Xc plus 2F2 at 673 kelvins at 6 atmosphere to give XCF4. Now XCF6 is also prepared by Xc plus 3F2 at 523 to 573 Kelvin at 50 to 60 atmosphere to give rise to a product XCF6. However, XCO3 is obtained by hydrolysis of XCF6. Therefore, XCF6, if it undergoes hydrolysis, give rise to XCO3 plus 6HF. Therefore, XCO3 is not obtained by the direct reaction of constituent elements, which is the correct answer. The following statements regarding helium is incorrect. A. It is used to produce sustainable and powerful superconducting magnets. B. It is used as cryogenic agent for carrying out experiments at low temperature. C. It is used to fill gas balloons instead of hydrogen because it is lighter and non-flammable. And D. It is used in gas-cooled nuclear reactors. Now let's look at what is helium. Now helium is twice as heavy as hydrogen. Its lifting power is 92% of that of hydrogen. Now, helium has the lowest melting as well as boiling point of any element, which makes liquid helium an ideal coolant for many extremely low temperature applications such as superconducting magnets and carrying out and used as a cryogenic agent for carrying out experiments at low temperature. It is also used in gas cooled nuclear reactors. Therefore, option A, B, and D are correct about helium. However, option C is incorrect since hydrogen is more lighter. It will let the balloons float, while helium is twice as heavy as hydrogen. Therefore, C is the incorrect option. The following inert gas liquefies easily: A. Kr, B. He, C. Ne, and D. Ar. Now, the maximum temperature at which the gas can be liquefied is called as its critical temperature, Tc. Now, the gas which has a high boiling point will change into liquid first, and so critical temperature Tc will be higher. Therefore, we can say that Tc is directly proportional to the boiling point. However, boiling point is directly proportional to the molecular weight. So, the compound which has the highest molecular weight will have the high boiling point and therefore will have the highest critical temperature, and hence it liquefies easily. Out of the four, Kr has the highest molecular weight. Therefore, the correct answer is option A.